Here today, we want to build a model, and obviously similar to previous sessions, as we build in this new model, we are going to learn three or four actually very important concepts. So let's first look at the model we want to build. So in this model, we have two entities. We call them part A and part B. These two entities come to the system. Each one of them go to their own machine for preparation. So we call them part A prep operation and part B prep operation. We know the operation time of part A on this machine has triangular distribution, and similarly for part B on this machine has triangular distribution with their own parameters. I have written the parameters here. And then after they go through the prep operations, then both part A and part B go to the sealer machine, okay? And each one of them is processed obviously separately on the sealer machine. However, the operation at the sealer machine is different for part A and part B, okay? Part A is triangular distribution. For part B, the sealer operation has Weibull distribution. Weibull, you write it as Weibull. I didn't write it here. I wrote the abbreviation WEIB, but you write it as WEIBULL if you want to write. So for part B, the processing time on the sealer machine has Weibull distribution. Part A has triangular distribution. And then after the sealer operation, they go through an inspection, and 91% pass this inspection process and get shipped. 9% of these parts fail the inspection and need to go through the rework. I forgot to write the rework time. So rework time is 45 minutes exponentially distributed. Okay, so rework time is 45 minutes exponentially distributed. And after the rework, 20%, after the parts go through the rework, they realize that 20% of them are scrapped, so you can't do anything. They have to be scrapped, but 80% of them get back to the good condition, and they are shipped. So they are the ones that were salvaged and shipped. Okay. So, and one other thing we know about this model is that for part A and part B, we know the arrival process. So we know that we receive 12 parts per hour on average. And for part B, we receive 30 parts per hour on average. And all inter-arrival times are exponentially distributed. Okay, so we know that as well. So we want to go ahead and model this this process. So one more thing that a couple of things here. First of all, this is the first time we are going to develop a model in which two separate entities come to the system and get processed, and that's fine. These are just that's not a big deal. We create two different create modules, okay? But this is the first time that these parts go on to get processed on one machine and one operation, and each part has a different processing time, okay? This is the first time that we want to consider the fact that when the parts finish an operation, it's not that all of them go to the next operation. Some of them go through this part of the process, some of them go through another part of the process. So we want to see how we can capture this in the model as well. And the other thing is very important is that when we run the simulation, when we develop this simulation and run it, simulation automatically generates some report for us. For example, since here we have two parts, simulation automatically generates everything we learned in previous session for part A and part B for each entity separately. However, what if I want to report some of the things that simulation doesn't calculate for me automatically? For example, what if I want to calculate the cycle time on scrap part? Because when I run the model, simulation report the cycle time, meaning the total time in the system for part A and part B. But what if I want to report the total time in the system for a scrap part separately, for salvage part separately, and for ship part separately? What if I want to do that? Simulation doesn't create that number for me separately. Simulation tells me automatically how many part A and part B came in, and how many left the system. But what if I want to know how many scrapped I created, how many salvage and shipped part I created, and how many directly shipped part I created? So if I want to report these numbers, I have to tell the simulation how to calculate these numbers. Okay, those numbers will not be calculated by the simulation automatically. And this is a very, very important feature of the simulation, because as you will use simulation for future work, consulting, and projects as well, you will see that you will be asked to generate or to report a lot of the things that simulation doesn't calculate for you automatically. So you have to calculate those, or when you develop the simulation model, you have to tell the simulation to calculate these things for me, and this is how you are going to calculate it. So it's very important for you guys to know how to do that part. And then the other part is related to this part, when your parts go through an operation and they are treated differently, when your entities go through an operation and they are treated differently. So we are going to learn all of those in this model. Okay, so and one last thing is that I want you guys to get familiar with this type of representations of the simulation models. I always recommend to my students, and for I myself, when I read a problem and I read a simulation model, it's always very, very helpful. If you guys just develop a graph like not a graph, figure like this on your scratch paper or on your notebook, and that give you a sense of what is the process that you are going to simulate. Obviously, when we are going to simulate, we add a lot of other modules and things like that, as you will see today. However, developing this will help you to make sure you have understood the whole picture. What I have seen in a lot of students is that they start reading the simulation, the problem, and without thinking about what they want to do, they immediately start clicking and putting the modules and so forth. And then when they go forward, then they realize, oh, now they have to calculate something which requires them to add maybe a module way earlier in the simulation, but they miss that part. So putting this representation of the model together in your notebook, it helps you to get a big picture of the model that you're going to develop and have a good understanding of what are the things you need to do at which point, so that you have a complete model when you finish. I strongly recommend you guys to adopt this practice as you develop the simulation models for practice, for homework, and more importantly for the project. It's going to be very, very helpful. Okay, and also I recommend that you guys, when I show these things, make sure to take a note and have that as you take notes during the class. Make sure also to take a note of these representations, because later that helps you to see how we develop the simulation. Okay, so now let's go and create a model. So create a model, call it, this is folder for week 5, right? Create a folder for week 5, and inside that model, create a pro model. Inside that folder, create a pro model. Sorry, create an arena file. Call it model 4.1, electronic assembly and test. And at the end, also add attributes. Can you see the name of my model? Because for me, the Zoom things is in front of the name of my model. Can you see the name of the model, my model in this screen?
Yes.
Okay, perfect. So at the end of the name, add attributes as well, because that's where we are going to learn this concept, which is a very, very important concept in simulation. Later, when you want to use this model, it helps you adding those things at the end of the name of the model helps you to know what did you learn in this model. So if you want to check something related to attributes, you can just open the model in which you learned the attribute concept. Okay. So with that, let's start the modeling. So everyone has created a blank arena model and has saved it in the folder for week 5, right? And we are going to use basic process panel. Okay. So what is the first set of modules? What is the first module that you would put in this system?
Create modules.
Okay, create. We want to create one create module for part A and one create module for part B. Okay, so let me go there and I said arrival of part A. Okay, now I want to count. I want to put the inter-arrival time for part A. Okay, so let's see what type of information we have. This is all I know about part A. We receive 12 part A per hour on average, and the inter-arrival times have exponential distribution. Angie, are you here?
Yeah, I'm here.
Can you tell me what is this information? How can you use this information that I have given you to fill the create module?
Because we have 12 part A per hour on average, so we need to use like like 60 minutes divided by 12. So it's the inter-arrival time of the minute.
60 divided by, okay, so 12 parts in 1 hour, okay? And each hour is 60 minutes.
Mm-hmm.
So first of all, tell me this information that I have given to you at this stage. What is it?
In 1 hour, there are two.
No. Is it arrival rate or inter-arrival time?
Is the arrival rate.
It's arrival rate because I'm telling you 12 parts per hour.
Yeah.
And what do we need in Arena? Do we need arrival rate or inter-arrival time?
Inter-arrival time.
Okay, so if I give you arrival rate, you have to translate this number into inter-arrival time. 12 parts arrive in 1 hour. So the time between arrival of every 2 parts is just 60 minutes divided by 12, which is 5 minutes. Okay. And in the video that I put for queuing theory, I also have shown you how to go from arrival rate to inter-arrival time and so forth. If you have not learned that, go back and watch that video. Okay, so you're right. So here, inter-arrival time is 5 minutes, but minutes, so change the unit of time to minutes. And what is the distribution of the inter-arrival time? Angie, are you here there?
Yeah.
What is the distribution of inter-arrival time?
Exponential distribution.
Exponential distribution. So you pick from the top, we pick exponential distribution is 5 minutes, and the units are minutes. Okay. Okay, thank you, Angie. Boya, are you here?
Yes, I'm here.
Okay, what is entity per arrival?
1,
Which means?
which means arrive 1 part A at one time.
1 part at a time. What is max arrival?
Infinite. There's no limitations.
Yeah, there's no limitation. For as long as we run the simulation, parts will come to the system. First creation.
I think 0 is. And also entity should be, we can create a part A.
Okay, that's good. Okay, and one more thing I have to specify here is that what is the name of the entity that is coming to the system? So I'm going to call the entity as part A. Okay, so this is the arrival of part A. I'm going to call the entity as part A. Inter-arrival time is 5 minutes, exponential distributed. So make sure to change everything that you need in this window. Okay, press OK. And then to create another create module. I'm going to put part arrival of part. The entity that is going to come to the system is called part B. And Ivan, are you here? Ivan,
Hello.
speak louder, please.
Oh, hello. Yes, I'm here.
Okay, tell me, how do you feel this part? What we know about part B is that we receive 30 part B per hour on average. What is the interarrival time?
So we have 30 parts arrival on 1 hour on average. So the entire arrival time for each part is 2 minutes. Yeah, 2 minutes per part. Right. So yes, 2 minutes per part, and it is exponentially distributed. So we have the type here is random and exponential, and each time we will have one coming out to our system. So the entity arrow is 1, and the max arrival, because as long as we run this process, it will come. The parts will continue arrival, so it's infinity. And we want, as soon as we run the process, the parts will come. So there's no delay or warm up. So the first creation is also 0.
Okay, that's correct. Just one thing, guys, I have to, so based on what I have given to you in the problem statement, what you said is correct. But here we need to correct this arrival rate for part B. We actually are going, instead of 30 parts per hour, we are going to receive 2 parts per hour, 2 part B. Please correct your note. Instead of receiving 30 parts B per hour, we are going to receive 2 parts B per hour, okay? Can you please just tell me one more time, if I receive 2 parts B per hour, what is the interarrival time?
That will be 30.
30, yeah, 30 minutes. Okay, so just correct that. So part B, we receive 2 part B per hour on average, and interarrival time is exponential. That means interarrival time is 30 minutes. Okay, so make sure to correct your note for that one, guys. And then we are good to go. Press OK. Okay. Thank you, Ivan. And then, okay, now. Remember I told you guys, when the part gets to the sealer, we want them to have different processing time on the sealer. And if you remember, if I just put an operation on Arena, if I just go ahead and put an operation on a process on Arena, if I just put a process on Arena, remember from previous example, I can just enter one processing time. Okay. However, here I'm going to create. I need to create a process here that is going to receive 2 entities, and that's fine. However, each entity has a different processing time. So we want to see how to do that. In simulation, there is a concept called attributes. Okay. The attributes, what is the attribute? This is, first of all, a very, very, very important concept. If I want to rank maybe the top 4 important concepts on simulation that gives you a lot of power and flexibility in developing complex model, attribute is one of them. What is the concept of attribute? Attributes are pretty much like a tag that you put on the entities. And as entities go through the different parts of your simulation model, we may need to check the value of these tags. And based on the value of these tags, we send the entity to different routes or do different operations on an entity, okay? So these tags, as I said, pretty much are when we create a tag, we put them on all of the entities, and then these tags may get different values. So let me ask you this question. So in all the students of USC, okay, if I define the students of USC as entities in the USC system, I'm developing a simulation model of the USC, and I'm going to treat the students as the entities in the system. They are the ones that are moving and so forth. So what do you think are some of the tags that can differentiate one entity from another, one student from another. Give me some example of these tags that exist, these attributes, these tags that exist that differentiate these entities from each other.
They could be separated by like what class they're attending.
Okay, that's one. What else?
USC ID.
USC ID, definitely each student gets a tag, or we call it attribute. And inside this tag, we have their student ID. And then as they go through different parts of the university, based on the value of this tag, we may do different operations and so forth. What else? And it doesn't need necessarily to be different from between all of this. Maybe we can just group them into two sections, this and that, but still each one of them has an attribute or a tag that can tell us which group they belong to, for example.
We can separate into undergrad or graduate student.
For sure, that's one. Some very important identity-related tags. Gender, can it be a tag?
Yes, and I think we can also sort the students by college, like commercial, Viterbi, yeah.
Yeah, exactly. So, for example, the age can be a tag, the college they belong to, it can be a tag, their race can be a tag, their student number can be a tag, and so forth, okay? Let's and as the students go through different parts of the process, based on the value of their tags, they may receive different processes or actions and so forth. Let's assume you are modeling a hotel, and the customers obviously are the entities in this hotel. What do you think are some of the tags that we can give to the customers?
Their reservation number? Or their room number?
Okay, but what would be some of the things that can help us in terms of the management? Can you think of a tag that I always can carry with me as a customer of this Hilton hotel, for example, and
Their room key?
those are all ones, but for example, the one that is very helpful is if they are VIP or not, okay? They can give a tag of priority, for example, to the customers, and if they are VIP, they get a tag 1, for example. If they're not VIP, they get a tag 2. And whenever these entities come to the hotel system, based on the value of these tags, they are treated differently, okay? Maybe their processing time is different, maybe the queue that they go to is different, and so forth, okay? So one very, very important application of this tag or attribute concept is capturing priorities in simulation model. You will use that a lot. For example, I have part A and part B. This is not the case in this model, but I'm just giving you an example. And both of them go to the sealer machine to get processed. However, part A always has higher priority compared to part B to get processed on the sealer machine. If that's the case, I can give a tag of priority to these two entities. When they get to the sealer machine, I'm going to look at the value of the priority tag, and I'm going to first process the ones that have higher priority. This concept is used a lot in the manufacturing, in the service industry, and so forth, and many more. So this whole attribute concept is the one that enables us to do that. So when we define a tag, that tag is given to all the entities in the model, and then we will tell the simulation later what should be the value of the tag for each one of the entities, okay? So we are going to use a similar concept here. So as I told you, if I put a process module in the simulation in Arena, I don't have the possibility to define two different processing time for part A and part B. I just can give one processing time. However, both part A and part B come to this sealer machine to get processed. So how do you think we can use the attribute concept or the tag value concept to take care of this part?
You can make it so that the program recognizes that if it's part A, it assigns a certain identification to part A, and then the similar for part B.
Okay.
So it can be tracked through the rest of the process.
Okay, so why not I give them a tag, I call it processing time on the sealer, okay? And in this tag, I save this processing time. So each entity that comes to the system, if it's part A right here, I know for sure this is part A. If an entity comes through this operation, I know for sure this is part A. Why not right here, I give this processing time as the tag value. And if a part comes through this process, I know for sure that's part B. Why not right here, I give this second processing time as the tag value. And when they get to the sealer machine, I will tell sealer machine, okay, check their tag values. Whatever the tag value says, it's their processing time. Does that make sense? Would that make sense? Do you think that looks correct, right? So we can do a lot of that with this tag or attribute concept. And that's what we are going to do, okay? I'm going to create a tag. I'm going to call it process time on the sealer. And I'm going to save for part A and part B, for each one of them, I'm going to save their processing time on the sealer machine on this tag. When they get to the sealer operation, I'll tell the sealer machine, go check the tag value. Whatever it is in the tag value will be their processing time. Okay, so we want to do that. So let's go back to the model. Okay, the function, the module that can help us to do that is called assign. Okay, so this is a new module that we are going to learn today. So the module, and we are going to use that a lot. This is a very, very important module. So we are going to bring the assign module 1 here for part A. And what I'm going to call this, I'm going to call this assign part A sealer. So put this name, I'll tell you in a second why. Sealer and arrival time. Okay. I want to do two things with this assign module, so I'll tell you in a second why. So give this name, assign part A sealer time, which is the one that we want to do right now, and arrival time. I'll talk about this arrival part in a second, okay? Now, if you have given the name, now we want to tell the simulation, okay, how to do it. So here in the assignment, we are going to click on the add, okay? So what is the type of the things that we want to give to this, assign to this entity? Okay, so that's the whole assignment. What do I want to assign to these entities? Open the type. I want to assign an attribute, okay? I want to assign an attribute. What is the name of this attribute? I'm going to name this attribute as sealer time. Okay. I'm going to assign this attribute as sealer time. If you click the attribute name, there are a couple that are default attribute name in the simulation model. We actually will end up using all of them. You will learn them. But here, the attribute that I want to assign is not one of these default ones, okay? So you can just define the name of the tag that you want to give to this attribute. So I'm going to call it sealer time because that's the time on the sealer machine. And what is the value of this? If you remember, the time on the sealer for part A has triangular distribution with parameter 1, 3, and 4. So what is the value here is try 1, 3, 4. Okay. So I'm giving a tag or attribute to entity part A. I'm going to call it sealer time. And what is the value that I'm going to save on this tag is a value from a triangular distribution with parameters 1, 3, 4. Okay, so that's what it means. Press OK. And then press OK again. And save this name because we're going to use it. So just, you can type it again, but in case. So for now, let's press OK. Okay. And we want to do similar thing for part B. So I'm going to assign, for this one, I want to say assign part B, sealer and arrival time. Okay, that's the second assigned module. And I'm going to, again, to add one assignment. And what do I want to assign here? Can you do that for me, Christian? Can you do it? This is for part B.
Yeah, it's you're going to do attribute, and then attribute name will be sealer time as well.
Okay, sealer time, it's already here. I'm not going to create a different attribute or so. Sealer time is an attribute I already created when I was doing the first assignment. It's already here, so I'm just going to pick it. Okay.
So just out of curiosity, if you were to type sealer time in there again, new, would it change it from different, from the assigned part A sealer and arrival time?
It shouldn't. However, I never recommend to do that, because sometimes based on a little space here and there, you may get it like a different, and then you get a bunch of errors and so forth. I always recommend that if you have created once, always pick it from the menu. That's the safest option there. So, and then here, what do I put? What do I want to put for the sealer time in this assignment operation? I want to put Weibel, which is WEIB, with parameters 2.5 and 5.3. So let me first tell you something regarding the Weibel distribution. Weibel distribution is something like this, okay? Based on these two parameters that we gave to the simulation, the first one is called scale parameter. The first one is called scale parameter. The second one is called shape parameter. Okay, Weibel gets two parameters. The first one is called scale parameter. The second one is called shape parameters. Based on the value of these parameters, this distribution has a different, so many different forms. It basically goes all the way from something similar to the exponential, which is the blue curve, to something similar to the normal, which is the red curve. Based on the values of the scale parameter and the shape parameters, there's a wide range of shape that this distribution can get. Okay, so and also the values that it generates is always greater than 0. For example, for normal distribution, we know normal distribution always goes from minus infinity to plus infinity. However, the Weibel distribution always generates values greater than 0, and it goes to plus infinity. Okay, so this is basically how it looks like. So for Weibel distribution, if you ever have any processing time, arrival time, or anything in the simulation that has Weibel distribution, so I want you guys to first have a sense of what is the shape of the distribution, and then know that this distribution is two parameters. One is called scale parameter. The first one is the scale. The second one is shape. Sometimes we may not give you I may not give you right away like this. I may tell you the distribution of part B on the sealer operation has Weibel distribution with the scale parameter 2.5 and shape parameter 5.3. So you have to know which one comes first so that you put the right number on the simulation, on the distribution. Okay. So now I'm going to go back to the assignment. So I want to again give this attribute which already created sealer time, and the parameters are 2.5 and 5.3. Okay, so have that as well, and then press OK. All good so far? Make sure to save, guys.
I have a quick question about arrival part B.
Mm-hmm.
Why isn't I'm sorry for the first tag, I'm going like back to the beginning a little bit. Why wouldn't it be for arrival of part B?
Why I don't put arrival of part B as well?
No, can you go to the arrival part B tag?
Okay.
No, to the left of that one.
Yeah.
Yes, ma'am. Why isn't the inter-arrival time 2 minutes? Because the way you have it right now, wouldn't it be?
No. I changed. I said that. I said I made a mistake here.
Okay, I apologize. I missed that. Thank you.
No. So don't worry. So we receive 2 parts B per hour. I wrongly, because in the problem, it gives you inter-arrival time. So I wanted to give you arrival rate so that you guys practice how to calculate inter-arrival time, but I put the number wrongly. Yeah, so we receive 2 part B per hour. So inter-arrival time is 30 minutes. So correct that in your notes.
Thank you.
Okay. Cancel. Okay, so make sure to save, guys, as we go forward. One more thing I want to tell you before we proceed is that remember I told you when I talk about this model, I told you that I want to calculate cycle time, meaning the time in the system for scrap part and salvage part and ship part separately. Okay, so simulation doesn't generate that automatically for me. Simulation generates 1 cycle time for part A and 1 cycle time for part B. It doesn't generate it based on scrap, salvage, and ship. What do you think, or how do you think I can use the attribute concept to help me to do that? Just, this is more a brainstorming. Just, I know I haven't taught you this, but I just want to see if you guys can think of using that concept for such calculations, because that's what you will do in the future. In the real world, assuming, forget about the simulation, in the real world, you have 3, for example, different sections for the scrap part, for the salvage part, and for the ship part. How can you potentially find out the cycle time for scrap, cycle time for salvage, cycle time for ship? How would you do that in the real world?
We actually estimate those values using like data, or you just watch them produce and see how many are they scrapped or salvaged.
Okay, so you just stand up next to the scrap part. Whenever a part gets scrapped, okay, you look at the time, right? However, and remember, you want to calculate cycle time, meaning that the time that this part has entered the system till the time that this part has reached to the scrap section. Okay, how do you calculate that for all the scrap parts? Don't you just, seriously, in real world, don't you just ask an intern to stay there? When the parts come in, you record their arrival time. Okay, when the parts gets to the scrap, you record that time too, and then the scrap time minus the arrival time is their cycle time. Isn't that the case?
Yeah.
Similar for the salvage. You let the parts come in. When they come to the system, you record their arrival time, right? The time that they arrived. When they get to the salvage, you record the time that they get to the salvage section. If you wanted the cycle time of salvage part, you calculate the salvage time minus their arrive time. That gives you the cycle time of all the parts that got salvaged. Okay, and then at the end, you report the average of those or maximum or those or whatever. Does that make sense? Wouldn't that be something that you would do if someone asked you to do it in the real world? So in the simulation, we are going to do exactly the same. When the parts come to the system, I'm going to record their arrive time. When the parts are leaving the system, I'm going to look at the simulation time at that time, and then the time at that point minus their arrive time gives me the cycle time. Okay, now tell me how I can use the attribute concept to implement this idea. Can I say that, okay, when the parts come to the system, I'm going to create a tag for them. I'm going to call it arrive time. And for each one of them, I save in this tag their arrive time. When they are done and they are in either scrap group or salvage group or ship group, I'm going to look at the value of their tag, which is their arrive time. And then I look at the simulation time at that point as well. And I say that scrap time minus their tag value, which is their arrive time, gives me the cycle time of that entity. Is that correct? So we are going to do the same thing in this model. So what do I need to do next? Tell me, what do I need to do here?
You need to create a tag before the part actually arrives to part A.
So I don't need, so that this doesn't need to be before, because this create module, it means it has arrived to the system, right? So it hasn't gone through anywhere. It hasn't gone through any process or anything. So the simulation arrive time is exactly what I have here, right? Now I have to create a tag and give this arrive time to that tag for each entity. Okay, so I can do that assignment of this new tag right here in this assignment module. Does that make sense?
That makes sense.
Okay, so let's click on the assignment module one more time. And that's why here in the name I told you, say assign part A sealer time and arrival time, because I want to create a new tag. And I'm going to call it add. So click on the add. I'm going to call it, so first of all, the type is attribute. I'm going to call it as arrive time. And what is the value of this attribute? So a keyword that you guys have to learn is T now. Simulation knows this keyword. T now means that the simulation time at that moment, when this line is run by the simulation, okay? So what does this mean? That means when part A entities come to the system, right there, when they have just come to the system, create a tag or an attribute, call it arrive time, and save the simulation time at that moment in the arrive time, because obviously each simulation arrives at a different time. So save the simulation time at that moment on this tag. So that will be arrive time of that entity. Also give them the sealer time, which we already talked about, okay? And I'm going to do that for all the entities, for all part B entities as well. So I'm going to...
Professor?
Go ahead.
So when you do this, you add the arrival time and do T now. Does the program automatically store the T now for each individual entity that arrives through that particular tag?
Yeah. Exactly. Because remember, so what happens here? What I tell this in the simulation, entities are created here one by one. They go through the rest of the process one by one, right? So every entity that is created first goes through this operation, whatever. And right here, I assign two tags to the attribute. One of them is arrive time, one of them is sealer time. For sealer time tag, I generate a random number from this distribution and put it in the tag. For the arrive time, I look at the simulation time, because it's T now. I look at the simulation time at that moment and I save it in this tag. And I do that for each entity that is going through this step.
So the program will not overwrite the T now time for one entity that goes through, and before that entity leaves the system entirely. Say there's another entity that uses this module.
No, because this is this is a tag associated with this entity, and that entity is gone, is somewhere here. Right now, the simulation is working on this specific entity that is here in this assigned time, and assigns the T now to that specific entity. The rest of the entities are done, and they are somewhere in the rest of the simulation. I'm not going to change anything for them.
Okay, so the T now is is like a unique ID then.
So it's the time of the arrival.
Okay, thank you.
Entity that is assigned to that entity.
Does T now has like units, or it is a number? Just
it's in minutes, I believe.
Oh,
It's the simulation time that they...
got it. Thank you.
Yeah, so in this assignment, we only work on that entity that is here. If there is an entity that already has received the arrive time and is somewhere else in the simulation model being processed or inspected or whatever, I'm not going to affect that entity at all. This assign module works on the entity that is already in the assign module, not other entities. Okay, so let's do that for the assign part B as well. So we already assigned the simulation, the sealer time, so I want to assign another attribute, and I'm going to call it arrive time here on the top. I'm going to call it arrive time. And here also I'm going to save T now, which is the simulation time at that moment. Press OK. Press OK. And make sure to save your model as we go forward. Then, okay. So we are good so far. Then, based on the graph we have, part A goes through a part A prep operation, part B goes through a part B operation. Each one of them has a different processing time, so this is easy. Part A goes through a prep operation. I'm going to call it part A prep. This is going to be a seize delay release. When the entity gets here, it's going to get a hold of the resource, spend the time that it needs, and then release the resource. So I need to add a resource. I'm going to call it as prep A. And what does this unit mean here? Yeshan, are you here? Yeshan Lu? Yeshan?
Yes, I'm here.
Okay, tell me what unit 1 means.
Unit 1 means that unit 1 means that that machine or resource, only one machine or resource serve that entity.
Only one resource is needed for that entity. That's correct. If I have 5 prep A guy in the system working, do I put 5 here? If you have 5 prep machine for part A, do you put 5 here or still you put 1?
Put 1.
If
You
why?
mean at same time, or I think it should be 1.
Because?
Because just the one resource to serve one entity.
Because we only need 1 resource. If I have 5 prep guy, I'll do that, specify that in the resource module.
Yeah.
Okay, I tell prep guys there are 5 of them. But here in this window, I put still 1, meaning that I just need 1 of those people for each entity. Okay, so that's 1. And then the distribution is triangular. Triangular 148. Triangular minutes. 1 4 8. Okay. Everyone is good so far. So make sure to change the units to minutes, and it's a value added process. Okay, so it's because it's the prep operation. It's a value added. That's okay. We want to do similar thing for part B. We have part B prep and seize delay release. The resource is prep B guy, and I just need 1 of those for each entity. And the distribution time, the process time is in minutes, triangular distribution with 3, 5, 10 minimum 3, oops, average 5, max 10. Okay, press OK. Make sure to save as we go forward. Everyone is okay? All good? Okay. Next, I need to put the sealer operation, and I just have one sealer operation. So let's go to one process. I'm going to put it here just so that it looks like what we draw. I'm going to call it sealer operation. And the sealer operation was also cease delay release. I need one resource. I'm going to call this resource as sealer. And I need one of those for each entity. So units is one. I'm going to, the name of the resource, I call this sealer. Now, what should I do about the process time? Remember, here, process time for each entity is different. And in the sealer operation, I have only space for one process time. So how should I take care of that? So if you click on delay type, you see constant, normal, triangular, uniform, blah, blah. There is one which is called expression. If you call on the expression and make sure you change the unit to minutes, if you change it to the expression, right here at the expression, I can enter my attribute name. Let me see if I can see it here. I can enter my attribute name, which was, I'm going to press OK and go back to the attribute. And right here, I'm going to copy the name of the attribute because it's just safer. So what I did is that I went to the attribute module. Here you see the two attributes we created, the sealer time and the arrive time. If you just double click on the row, this window opens. Here on the top, you see the name you gave to this attribute. I copied that, and then I click on the sealer operation again. And here in the expression, I put sealer time. Okay, so that means for the sealer time, always go and check this attribute value. Whatever is in this attribute value is the sealer operation time, and which is in minutes, and it's also a value added operation. Okay, so this is how I'm using the attribute sealer time to tell the simulation that the sealer time operation is different for each entity and is saved in their tag called sealer time. You can also type it, that's fine, but I always do copy paste because there's a lot of errors when you type. Everyone is good so far?
Yes.
Okay, so make sure to save, guys, as we go forward. The next thing here that we want to talk about is that after the sealing operation, they go through an inspection. And out of 91% passed the inspection, 9% failed the inspection. So how we should capture that? So this is something we haven't done in the past either. So for those situations when some parts go this way, some parts go that way, we have a module called decide module. So we are going to bring that module next. Okay. So what is going on in the decide module? If I click on the decide module, I can basically write whatever we are going to check in that module. So let's say I call this failed sealer inspection. Okay. So that's basically the question we want to ask. Do we fail the sealer or not? And the sealing operation. And here there are a couple of two windows. So one of them, the type. If you click on that, you see two-way by chance, two-way by condition, n-way by chance by condition. First of all, here we have two-way because they either pass or fail. So just pick two-way. We will actually use n-way in other examples. You will see how that works. And here is we are choosing by chance because we want to give numbers with this percent chance, with 90% chance, 91% chance, 9% chance, and so forth. Condition is what we also learn later. If you sometimes you have a condition that if, for example, the tag value is greater than this, go this way or that way, we will learn those. Those are the condition scenarios. But here it's just purely chance probabilities. Okay, so we are going to use a two-way by chance decision node. And then here, it's a, what is the percentage if we want to do the true? What is the true here? True is, have we failed the sealer operation? So this is the true, right? So why do I say true? Because when I ask you, has it failed the sealer operation? If you say yes, if the answer to that question is yes, that's considered as true, okay? Has the part failed the sealer operation? Yes. What is the chance that they failed the sealer operation? Is 9%. Okay, so that's how you know what is the percentage that you have to put here. Because if I go back here, there are two percentages. One is 9, one is 91. Okay, the way I define this decision module is that I say, I ask the question, has the part failed the sealer operation? If you say yes, if the answer to this question is yes, that's the true. What percentage of the time the answer to this question is yes? 9% of the time. So you can define the decision module in any way you want. Just make sure, just be mindful about the question you are asking and what is yes to that question, and just put the probability of that here. That means true for your decision module. Is that clear, guys? Okay.
Professor, is that the percentage a fixed number or it is on average?
No, it's just it's not average. It's just a percentage, because here the problem told us that parts, after they pass the sealer, they go through inspection. And based on the past experience, we have seen 91% of the parts pass the experience, 9% fail the experience. And I asked the question, have I failed? Yes. Yes means failure, which means 9%. No average. These are just numbers that are given to you in the problem.
But how do we get that percentage in real life?
In real life, you have collected some data of previous inspection processes. So let's say you have a data sheet in which you collect the data of each inspection operation. And then let's say you look at the data of the past month. You have maybe inspected 100 parts in the past month. And when you look at the parts that have failed, only 9% of them have failed. And then that becomes your number. So a lot of these numbers that come here, the processing times, the percentages, and so forth, are based on the historical data that you collect from the process. If by any chance you have no historical data, they have collected no data, whatever, I will talk to the people who are in charge of these operations, or the people who do the inspection process, and then say, okay, based on your past experience, what percentage of the parts fail or pass or so forth. So you get a sense of these numbers. And then at the very end, when you finish the simulation, since you didn't collect any data for these numbers and you just get them from a guy who gets them, you can perform some sensitivity analysis on these parameters that you just estimated, and they are just rough estimate, and see how changing these numbers can affect your results. If changing this number from 9%, for example, to 15% suddenly change your results dramatically, then you know, okay, this is actually a critical parameter in my model, so I shouldn't just trust a person who just said 9%. So I have to spend the time, collect data. So just put everything on hold, collect data for another week or two to be able to get a better estimate of these numbers. Do they make sense? Does that make sense?
Yes, thank you very much.
Sure. Okay. So that's that. And then from there, okay, if we are true, where do we go? If we are true, 1 second. Okay. If we are true, we are going to go through some rework operation. Okay. So let's put the rework operation here. And if you here look closely, oops, this one is true, this one is false. Okay, so if the part has failed the sealer operation true, meaning the part has failed, I'm going to put a rework process right here. Okay, if the part has not failed, meaning that they're going to be shipped, that's going to be this other section, which is false. Okay. So let me go back and put a process right in front of the true, meaning the part has failed. So they have to go through a rework process. Rework process. And this is going to be another sys delay release. And for the resource, I'm going to call it as rework resource, and I'm going to just use one of them to do the job. And the rework operation, I did not mention it in here. I forgot to write it here, but I said when I was explaining the problem that is 45 minutes exponentially distributed. So let me go back here. So it's going to be expression because I don't have exponential here. It's going to be in minutes and it's going to be x 45. Okay, that's that. And press OK. Now, after the rework operation, everyone is good so far? Are you with me? Are you behind? Do you want me to wait? I assume no answer means we are good. Okay, so after the rework operation, what happens? Another checking, 20% of them get scrapped, 80% of them get salvaged and get back, they are shipped. Okay, how should I capture this part, guys? You already know it.
You use the side.
What is it? What should I put after
the diamond shaped thing?
Okay, another decide module. And I'm going to call it failed rework inspection. Okay. Am I going to should choose two-way or more? Two-way or n-way?
Two-way.
By chance or condition?
Chance.
Chance. And what is the percentage of the true? Remember, failed rework inspection. If you answer yes, that's the true. Failure. What is the probability of true here?
Lose 20%.
Meaning that you have exactly. Meaning that you have failed the rework process. You have been scrapped. So the failure is then 20%. That's the true in this scenario, the way I worded this decision module. And the other one is 80%. So again, if you look at this closely, so if you fail, you get a scrap. That's the true. If you pass, you will fail. If you pass, then you pass. Okay. Now, one thing I need to mention here. Now, remember I told you, so we are good. If we can put just a dispose module here for everything that is scrap, a dispose module here for everything that is going to be salvaged, and a dispose module here for everything that has passed the inspection and is going to be shipped. Okay, if that's the end of the model. Okay. However, remember I told you guys that I need to create. I need to calculate the cycle time for each one of these operations, for each one of these salvage part and scrap part and ship part separately. Okay. So then before I let the entities leave the system, I have to do those calculations and I have to collect those statistics before I put the dispose module. Because if I put the dispose module, they are out of the system and they're gone. I can't do anything else. if I want to collect any statistics that simulation does not calculate for me automatically, I have to do it right now before I put the dispose module. Okay, and this is what I can do here. The module that is going to help us to do that is called record module here. This is a very, very important module. So here in the record, we can tell the simulation to record a couple of statistics that simulation doesn't create for us automatically. So bring the record module and let's put it here, because I want when we fail the inspection, when we fail the rework inspection, that 20% which become scrap, so they get to the to this record module. So let's put the record module right here, and then let's double click on that. So here I'm going to put what is the name? Record scrap part. Okay, so here I'm going to collect a bunch of statistics for scrap. So one of the things that I want to calculate is their time, the time that they have spent in the system. So let's, in the statistics definition, let's just add. Okay. Here you have a bunch of statistics that you can collect. What I want to collect here, when I click on the type, there are a bunch of things. What I want to calculate here is called time interval. Okay, it's time interval. Because why? Because this right now, I want to calculate the time interval they have spent in the system from the time that they came in to the time that they have left the system. Okay, so this is in the category of time interval. So I calculate pick the time interval, and then here it tells me, it knows that it's going to calculate the time interval, the cycle time. So it asks me, what is the attribute name that I'm going to use? Okay, the attribute name that has the arrive time of the entities is listed here. So when you open this arrow, so you can see arrive time. So pick the attribute name, which is arrive time, and then that's the one that is going to be used to calculate this time interval. And then what is the name of the tally? So I'll tell you in a second why we call it a tally, but here is the name that you want to give to this statistics. The name that you give here is the one that you see when you run the simulation in the report, you see this name. So tally name, let's say record scrap cycle time. Scrap parts cycle time. Okay, so that's what I want to call this tally. So I'm going to call it as a tally. Okay, so here in this record module, so the record module is very important module. You are going to use it pretty much in every simulation. It helps us to calculate a bunch of statistics that the simulation does not calculate for us automatically. You just give a name to this record module. Here I want to calculate a bunch of statistics related to scrap parts, so I say record scrap parts. The first statistics that I want to calculate is in the category of time interval. The attribute that I'm going to use to calculate these statistics is the arrive time attribute. That's the one, that's the tag we gave to each entity, and we recorded T now when the entity entered the system, which recorded the time of the arrival of the entity to the system in that tag. And I'm going to use that to calculate the cycle time. And I'm going to recall these statistics as scrap cycle time. All good so far? Press OK. And press OK as well. Okay, so let's calculate one more thing. Let's click on the record scrap record one more time. So let's assume I also want to calculate how many parts got scrapped. Remember, I told you simulation automatically generates for me how many part A and part B came to the system and how many part A and part B left the system. But simulation doesn't tell me how many parts got scrapped. And if you need that to report to your boss, you need to calculate it yourself. So again, but that's something that we can calculate with the record module. If you go here, right when a part gets scrapped, goes through this part of the decision module and goes to this record module, I not only calculate how long they have stayed in the system, but I want to also count them. Okay, so let's add another statistics. For this statistics, I'm going to use count because it's not in the category of time interval or something else. It's just a count. Every time an entity gets here, I want to increase the count. I'm going to call it count. I'm going to increase the values by 1. Every time an entity gets here, I'm just going to increase this counter by 1. And here, this entity is going to count a scrapped part. So this is the count number of scrap parts that are leaving the system. So that would be the name of this statistics that I just created, and that's the name that we are going to see when we run the simulation model. Okay. So this type of statistics that I pick is in the category of count. Press OK, press OK, and click Save. Okay. Before I go further, I need to mention something. Regarding the statistics that we calculate in the simulation, the ones that we calculate with the record module, they are in 3 categories. One of them are some of them are in the category of counter, like the ones that we just calculated. Okay. So what are the counter entities? The counter entities are the ones that we, like the ones that you just saw. If we want to count something, we use a counter statistics. So these are just some counters. You can increase them by any amount that you want. You tell the simulation, increase them by 1, increase them by 2, 3, or whatever, or even decrease them by whatever. But these type of statistics are in the category of counter. The examples: number of parts that passed the inspection, number of parts that failed the inspection, number of parts that got scrapped, number of parts that passed a specific operation. If you want to count anything in the simulation, you use these type of statistics. We call it counter. And that's important to know, because anytime you want to, in the record module, you want to create a statistics, it's important for you guys to know, is it a counter category or something else? Okay. So that's one. The other one is called tally. Oops. The other one is called tally statistics. Okay, what are the tallies? If you collect data on something, and then at the end, what you want to report is average of those numbers, their minimum, their maximum. Those statistics are in the tally category. Okay, can you give me some example of those? The simulation has collected data on a bunch of things, and then at the end, simulation reports the average of those numbers, their minimum, their maximum, confidence interval, and so forth. Can you give me some example of such numbers? You already have seen a bunch of them in the report that the simulation generates. We just defined one of them here. For this one, it asks you, what is tally's name? What do we calculate here? Remember, in the record module, I put 2 statistics that I want to calculate. One of them is time interval. I called it time, is in the category of time interval. Can you tell me what does this tally remember here it says tally name, I put it scrap cycle time. Can you tell me what this tally calculate for us? Christian?
It calculate the minimum, average, and maximum of the scrapped cycle time.
Exactly. For each part that has been scrapped in the system, it calculates how long that part has stayed in the system. That's the cycle time of that part. At the end of the simulation, let's assume 100 parts got scrapped. At the end of the simulation has 100 cycle time for all 100 parts that got scrapped. And then it's going to report the average of those numbers, their minimum and their maximum. Okay? And that's what we call a tally. Okay? So we have a bunch of them, cycle time, I don't know, the time in the operations and so forth. So tally is one. And the third one is time persistent. Time persistent statistics. Okay. So time persistent statistics is a little different. Okay, let me ask you this. Assume I'm looking at the parts in the queue for an operation. I'm looking at the parts in the queue. Remember, one of the numbers that simulation generates for you is number of parts in the queue. I'm looking at the number of parts in the queue, okay? And I see, and I'm looking at the queue for 10 minutes. Let's assume I do that. I look at the queue for 10 minutes, and in this 10 minutes, I write down number of parts that I see in the queue. Remember, assume that at time 0 when I start, there is 0 part in the system. So I start at time 0. There is 0 part in the system. And then I continue, go all the way to, let's say, time minute 8. And then right there, oops. So at time 0, there is 0 part in the system. 1, 0, 2, 3, 4, 5, 6, 7. Right at minute 8, 1 part comes to the system. And then at minute 9, that part also leaves the system. So I again go back to 0 and then 0. Okay. So the total number of parts, the number of parts that I have seen in the queue are either 0 or 1, right? For 8 minutes, I saw nothing. And then at minute 9, let's say 1 part came. And then that part was in the system just for 1 minute and then it left. So at minute 10 again, I came to 0. Okay. And I asked you, what is the average number of parts in the queue in this system? What do you report? The number of parts in the queue in this system has been either 0 or 1 in this 10 minutes that I have observed this queue. And I asked you, what is average number of parts in this queue for these 10 minutes? What do you report? Do you just say, oh, I observed 0 and 1, nothing else? That 0 plus 1 divided by 2, that's the average? Is that what you report?
Actually, I think maybe it is weighted by like time because you have 9 zeros in the and only 1 count of 1, so it's 0.1. I guess.
Exactly. If I just say simple average of 0 and 1, because those are the 2 options of number of parts in this queue, and just add that and divide by 2 simply, that's a very, very wrong number in terms of the average number of parts that have been mating in this queue. If I have seen 0, 90% of that 10 minutes, and number 1 only for 10% of that 10 minutes, then I have to consider that time components or those percentages in the calculations. Okay, so those are what we call as time persistent statistics, meaning that the time that you have observed those values in the simulation, in the system, is going to be used when you calculate the average of those numbers for number of parts in the queues, for number of parts in the system or work in process. And these statistics, when we calculate them in the simulation, those are time persistent statistics. So they are not just simple average or things like that, like what tally was. For tally, I look at the cycle time for each part, and at the end, I just report their simple average. There is no time persistent concept in the tally. I just calculate the simple average as the average cycle time in my simulation. But for time persistent category, when I look at the possible values, I also have to know how long in the simulation this value was observed, how long this in the simulation the value of one observed, and so forth. As I said, examples, number of parts in the queue, number of parts in the system, and a bunch of other statistics that we are going to calculate that simulation doesn't calculate for us, and they are in the time persistent category. It's very important for you guys to know. So these are basically types of statistics that we calculate in the simulation. Okay. So when you calculate any statistics in the simulation, it's important for you guys to know, is it in the counter category, is it in the tally category, or is it in the time persistent category? Because each one of them needs different selections, a couple of different settings, and so forth. It's important for you guys to know what you want to calculate falls in which one of these categories. Okay. Let's go. Any question, guys, so far? If no, let's go here. Okay, press OK. And then for the, and then we want to, okay, so after the record, what is then? After the record, this part is going to be disposed. So this is just a dispose of scrap parts, okay? So press save. And then we also want to put a record after the this part, record for this section. So later with an arrow, I connect the false part to this section. So here I'm going to call it as record salvage parts. So how should I calculate the cycle time for salvage parts? Add. What should I count? What should I pick here? Time interval. And what is the name of the attributes? Yeah. The name of the attribute is, no, arrive time. And what is the tally's name? I'm going to call it salvage cycle time. Press OK. And let's assume we also want to count how many parts got salvaged. So the second one is a counter. And I want to increase this counter by 1 every time an entity gets to this point. And I'm going to count and call this counter salvage part. Count salvage. Okay. Okay. Press save. And So here, it may not be a bad idea to connect these decision module to this record module so that we don't get confused later. And we are going to put a dispose for all the parts that got salvaged. Okay. And what else is left here to be done, guys? What do I miss here? Oops. Can you tell me what do I miss? Where should I?
think
Record for the shipped parts.
Which part?
Parts.
Okay, the record for these parts that do not pass, that pass the sealer inspection, right? Is that what you said? When you create these modules, if it automatically generates these connections for you guys, just delete them. Okay, in this record module, so I want to take care of the parts. Remember here in this decision module, we said sealer operation. Do I pass the sealer inspection? If you fail, okay, you go to the rework process. But if you pass, you come to this record operation. So what I want to record here is the record. Let's say cycle time. So let's say record directly shipped. Because here I want to calculate the cycle time for the ones that were directly shipped. They didn't go through the rework at all. They were directly shipped. So add time interval. What is the attribute?
Arrive time.
And I want to call it directly shipped cycle time. Okay. So we want to do that. Press OK. And then let's also count number of ones that were directly shipped. So it's a counter. I want to increase it by 1, and I'm going to call it count directly shipped. Okay. Press OK. Okay. And then I need a dispose module for here. So dispose directly shipped. Okay. And if you have done all of that, make sure to connect this module. And always when you connect, make sure to go from the ones that starts the connection to the ones that end the connection. Don't go the other way, otherwise you get error when you run the simulation. You can double click. If you double click on the connection, it stays active and you can just do all the. Okay. Everyone has this model. Do you want me to show any specific module? Do you want me to open the window for it? Are you guys good?
Professor?
Yeah.
Quick about the sealer operation process.
Which one?
The process called the sealer operation.
Okay.
Yes. I don't really understand like how you how you're using the sealer time as the expression?
Okay, so remember sealer time is the tag that every entity has, and that tag contains the processing time on the sealing operation for that entity, right? That's the one that we define here. We gave a tag, an attribute to each entity. We called it sealer time. And in that attribute, in that tag, we generated a random number from this distribution, triangular distribution with parameters 1, 3, 4. We generated a random number from that and save it in that tag. Okay, so every entity that gets to the sealer operation already has a tag called sealer time in which there is a number, and that number is processing time of that entity on the sealer machine. Okay, so how should I tell the simulation this process? So I tell the simulation that the process time on the sealing operation on the sealer machine, the process time is not constant, is not normal distribution, is not triangular distribution, is not in uniform distribution, is an expression. Okay, and remember here for the expression you can just write a bunch of things, add numbers, divide, whatever you want. Okay? What I say here in the expression option is that go and look at this tag value, sealer time. Just check the value, check the sealer time value. Whatever is in the sealer time is the process time. And the sealer time is the tag that every entity has in which there is a number. That number is the one that I assigned to the entity in these assign modules. And that number tells the sealer operation what is the process time of that entity on the sealer machine. Okay. So that just tells, it could be a variable or a bunch of other things that we are going to learn later in the simulation. But here it just tells the simulation that the sealer time operation is in the sealer time attribute. Go read whatever is in that attribute, use it as an operation time. Does that make sense?
Yes.
Okay.
Yeah, I get it. Thank you, Professor.
Sure. Guys, make sure to save as we go forward. And I think...
Professor, can you go to the rework process?
Sure.
I'm not, I mean the rework process.
The rework, I'm sorry.
Yes, no worry.
How do you say arrival? Rework process.
Rework, yes. I'm not sure like where did you get the exponential function from?
I said that several times that I forgot to write it here, but the rework process has exponential distribution with average 45 minutes. I should have written it here. I forgot, but I'm just saying.
Okay. Oh, sorry. I just want to make sure that
Sure.
it will appear, I mean, somewhere in the problem or that.
No worries. Always ask your question. No worries. Any
Thank you.
question, guys? Sure. So let's now go ahead and run the simulation. So everyone can see my screen, right? So just make sure it's shared. Let's go to the setup. And here, I'm going to run the model for 4 days, and each day is 8 working hours. Okay, so 8 working hours each day, and for 4 days, so that's 32 working hours. Okay. And when I report the results, I want the unit of the time to be minutes. So if it gives me the time waiting in the queue, the time waiting in the system, I want those to be reported based on minutes. So that's why I changed the base time units to minutes, but I want to run the simulation only for 1 replication, and that's going to be 32 hours. So remember here, I told you I want to run this for 4 days. Each day is 8 hours, so the total is 32 hours. So here I'm assuming that at the end of the first day, at the end of the first 8 hours, wherever the model is, the simulation is, the factory is, that would be the same at the start of the second day, which is right at the start of hour 9. Okay, so at the start of hour 9, I'm going to start from wherever I left off at the end of hour 8, meaning that at the start of the second day, I'm going to start from wherever I left off at the end of day 1. Meaning that if you want to run this model for 10 days, you don't have to necessarily tell the simulation model is 10 days, each day is 8 hours or whatever. You can just straight run it for 80 hours. Since this is a manufacturing process, this assumption is correct. In a manufacturing process, we leave at the end of the day, everything is left like that. We come back next day, we start the process from where we left off the day before. Okay. However, this is not the case for all the systems. For example, if you go to a supermarket, every day they make sure everyone is out. The start of the next day, they start with 0 customer in the system. So we'll have actually one chapter talking about these 2 different systems and how we should change the things in the setup window to run one system versus another. But in this system, it's okay to run the system for 32 hours. If each day is 8 hours, that means 4 days for this model. Does that make sense? Make sure to go to the project parameters and make sure the entities, resources, queues, processes, most of the times are not checked, but I always check those as well. It's good to have these 4 things checked so that we see their statistics reported. And if you're done, press OK and then press run. If this is scroll, on the top, this blue scroll, if you move it to the right, your simulation runs faster. If you move it to the left, your simulation runs slower. If you move it to the right, your simulation goes very fast, and then you see the results right away. So use that, especially during the exam, because you don't want to sit down like just there waiting for the results to be shown. Okay. Did you get similar numbers? Okay, guys, we see the value added time, the time that the part has been processed, this part, and we see the results for entity A, entity B. If we have more entities in the system, we see the results for each one of them separately. The waiting times, the total times, which is the sum of everything we have here on the top, and here, since we only have value added time and wait time, the total time is just the sum of those. If I go to the other, number in, we have number in and the number out for each one of them. Can you tell me why part B is a lot less than part A? The number of parts B that came to the system is a lot less than part A?
Because the inter-arrival time is 30 minutes for part B.
The inter-arrival
So makes the number of entity enter the system less than part A.
Yeah, exactly. For part B, they enter in the system every 30 minutes, but for part A, they enter every 5 minutes. And then we have number out, where the working process has been calculated. Okay, for each one of them. For part A, obviously, we have a lot more in the system. So the question I have from you, working process, everyone knows what is working process, right? Can someone tell me what is working process?
It's how many parts are in the system at any given time.
At any given time. My question is that, can you tell me working process in which category? Is it a counter, is it a tally, or is it a time persistent statistic?
It's time persistent.
Okay, why?
Because at each moment there is a certain number of like working person, and you average over like time, not like count or
the time that they have been. Obviously, it's not a counter. We are not just increasing something by 1 or 2 or 3 or whatever over time. It's not a tally, because when I have obviously a bunch of numbers. These numbers show the number of parts that have been in the system at any point of time. But I can't just report a simple average of them. Similar to the example I gave you here. I can't just say, oh, I have observed 0 and 1, so the average is 0.5. I can't just look at their simple average of them or their mean or max, and that would be the tally. I have to calculate a time persistent statistic. I have to calculate average of these numbers, but a weighted average. And the weight that I give to each number is how long I have seen those numbers in the system. So work in process is a time persistent statistics, because the numbers that I see in the system in terms of how many parts are in the system, I just shouldn't report the simple average for each one of them. I also have to take into account for how long I have observed 3 parts in the system, for how long I observed 2 parts in the system, for how long I observed 10 parts in the system. And those long time intervals for which I have observed 2 or 3 or 10, whatever, I use them in calculating the average as a weight factor. Okay, and we have again processes, queues, and resources, and all those that we checked. There's one that we haven't seen so far, that's user specified. Those are the things we define. So if you click on the user specified, you see tally, you see counter. You remember, these are the ones we define in the record. So we for the tally, for example, if you open the plus part, so for the tally, I calculated the directly shipped cycle time, salvage cycle time, and a scrap cycle time. So I calculated 3, and they are in the time interval category, but they are under, all of them are under tally category. And then for the counter, I also created 3 counters for each one of these 3 type of exits that I have, and they are all under the counter category. I did not calculate any time persistent statistics, so that's why we don't see that option. Otherwise, you would see tally, counter, and time persistent. And if we calculate any time persistent statistics, you will see it there. So it's very important for you guys to know this, how to use this user specified and how to get the values for each one of them. For example, if I go to the tally, I see the cycle time for directly shipped. I see the cycle time for salvage part and for the scrap part. And as you can see, obviously for scrap part and salvage part, the cycle time, which means the time in the system, is more than the directly shipped part because they go through the rework. Okay, since they go through the rework, and rework alone was 45 minutes, if you remember. And the fact that these numbers, the cycle time for the parts that go through the rework is a lot more than the parts that do not go through the rework, then can give us some clue that, oh, they are waiting a lot for the rework. Not only the rework time is long, with this 45 minutes, but also they wait a lot to go through the rework. So this rework process should be like a bottleneck. The parts wait there a lot to finally get processed. Where can I go to verify this hypothesis that I have? I'm looking at the cycle time and I'm like, oh, the cycle time for this salvage part and the scrap time, because these are the only 2 parts that go through the rework. And if the time in the system is just a lot, that means something is going on with the rework. Where can I go to check on the waiting time for the rework and make sure those numbers are high?
Can we go to the queue?
We can go to the queue. And if we look at the rework process, yeah, you see the waiting time for the rework, it's 253 minutes. It's a lot more than the rest of the queues that we have in the system. So that definitely confirms that hypothesis that yes, something is up with the rework operation. Maybe we have to increase number of workers or something, or find a way to perform the rework in a shorter time, but obviously there's a lot of waiting time for the rework. If I was the analyst of this system and I would just look at the result, that would be one of the things that I would report to my manager, that there's something up with the rework. The rework time is long, it's 45 minutes, but still, even if we just put that aside, still they spend about 200 minutes just waiting in the line. That around 250 minutes waiting in that line. So we have to do something about the rework.
Professor, I have a question. Is there any correlation between the waiting time and the utilization rate of that resource, or can we just go to
waiting time is just in the queue, okay, before they get processed. If I go to the operation, if I go to the operation, the waiting times is everything before they get to the queue. Let me stop so that you see. Okay, so there's a queue here, right? You see, when a part wants to go for the rework is busy, they go wait in this queue. So the waiting time is all about the queue. And, but utilization is about utilization of the resource when a part is being processed. So the numbers are completely reporting different things. However, you may be able to say that actually if so many parts are waiting, that means this guy is also busy all the time, right? So however, though that's the general rule, but I want you guys to know these two, the waiting in the queue and the utilization, report two totally different things. One of them is about what happens in the rework. One of them is about what happens in the queue rework.
Okay, thank you.
Okay. And yeah, and then you can just go over the, let me see what else I want to entity. Okay. Yeah, you can go through the rest of them, like later after the class, you can go through the rest of them, check a bunch of things. So make sure you guys know what each number means, where to go to get what. And this user specified is the new part that we never had before, where you can see it is the statistics that you wanted to record in this system. So for example, if we look at the counter, that's a good one. It shows 424 were shipped directly, 34 were salvaged, and 8 of one of them was scrapped. So that's actually a good number. So that gives you a sense of what's going on in the system. Of all the parts that were through the rework, we actually did good. We could salvage 34 of them, and only 8 of them got rejected, got scrapped. Okay. And any question, guys? So if you are
Professor, I have a question.
Go ahead.
I just want to make sure I get the concept of time persistent data. Is utilized also the time persistent data?
Exactly. Utilization is definitely a time persistent statistic, because if a machine has been utilized, let's say 100% of the time for 9 minutes and just has been idle, which means 0% utilization just for 1 minute, and I'm looking at the machine for 10 minutes, I don't want to just say, oh, the utilizations I have observed are 100% and 0%. The average of these two is 50%. So this machine has been utilized 50%. No, this machine has been utilized 100%, 9 minutes of that 10 minutes, and only 0%, 1 minute of that 10 minutes. So if you want to report the utilization of that machine, you definitely have to take into account the time, for the time interval for which you observe 100% and 0%, and definitely utilization is a time persistent statistic. It's a very good point.
Okay, thank you.
Sure. Okay, guys, make sure to save. And let me just say one more thing before we finish up this one. Okay. One thing I want to say is that, first of all, the attribute data module, we have it here. If you want to change later anything about the attributes, you can do it here. If you want to define your attributes first and then use them in the model, you can do that. And I actually personally prefer that a lot. If I know I'm going to use an attribute called sealer time, arrive time, whatever, maybe I come to the attribute data module, and here you see double click here to add a new, let me just save it first. Here, at the bottom, if I double click, a new row is created. Here I can create a new attribute and so forth. And you can do that and then go ahead and use them in the model wherever you want. Okay, so we can do that. Here I'm just going to okay. And then one more thing I want to mention here is that the entity data module, if you click on the entity data module, you see both entities we created, part A and part B. I think we used that in previous sessions. I'm not sure, but I'm just going to repeat it. So when you run the animation, both these entities are like black little dots that you see in the simulation. However, sometimes it may help to represent your entities with different colors so that you can track them in the simulation. You see what's going on. If the parts are waiting in a queue, you see, are they mainly the part A or part B and so forth. So you can give them different pictures. So here, for example, if I click on the initial picture, I can give them blue ball, for example, here, and the other one, I can give it a green ball. I think this is a green ball or whatever. Yeah, you can give different colors, blue ball and green ball, and as a result, save. And when you run, you see some of them are blue, some of them are green, and obviously you can increase the size so that you can see them closely. But changing those colors helps to see what's going on in the animation of your simulation. And one more thing I want to mention here is that, guys, here in this part, if I just put one dispose module instead of three, if I just put one dispose module and direct all of the entities to that in dispose module after we are done with the recording, would that be wrong? So instead of three dispose module for scrapped, for salvage, and for directly shipped, I'm just going to create one dispose module here, let's say, and I'm going to connect it to this record module, to this record module, and to this record module, meaning that whenever I'm done recording the statistics, all of them go to this dispose module and they get disposed. Then I don't need three dispose modules, I just need one. Is that correct or not? Yes, correct. It's absolutely fine because this is just the dispose part. It doesn't do anything. So you can just put one dispose module and just connect all of these, the record modules to the dispose module. The only reason we did three is just, first of all, for you guys to understand better what is happening. And second, we can create animation for these models like a little better than the one that we see when we run the simulation, a little more animation, better animation with graphics and everything. And if you want to do that, we have to have three different dispose modules to do that. But for the sake of simulation, for the logic of simulation, it's not necessary. We could have just one dispose and it would take care of all these three. We would get rid of these three and we just put one dispose. Next question. If I only wanted to record, for example, if I just wanted to calculate cycle time, I know the simulation calculates the cycle time for mirrors, or if I just wanted to calculate the cycle time of all the parts, no matter if they are scrapped or salvage or they're directly shipped. I want to calculate the cycle time of all the parts, and I don't care if they are part A or part B. I want to report one cycle time, which is for all the parts in the system. Can I just put one direct module, one record module here? Can I just put one record module here and bring all the parts from all these decision sections to this one record module? So Basically, I want to create. Oops. Sorry guys for the background noise. Can I do that to just create one module and direct all the entities to that module, no matter if they are scrap, no matter if they are salvage, and no matter if they are directly shipped? Yes. If you want to create something that is just calculate things for all the entities, no matter what type they are, you can just do that in one record module and direct all of the entities to that record module and don't worry about anything. Here we created 3 different record modules because we wanted to do the calculation for salvage part and for the scrap part and for directly shipped part separately. For each one of them, we wanted to record separate statistics. That's why we created 3. But if you want to record something for all these entities that doesn't differentiate between them, you can just create one record module and you are good. Okay. Any question, guys? Okay, make sure to save and close this model.
I have a question actually.
Go ahead.
So here we calculated 2 records for our decision node that like the name is failed rework inspection, but all it happens here is just calculating 2 probabilities. So like one of them it has 80% chance and the other has 20% chance. So if we just included this probability in an attribute in the record, so we could do it in only one record, right? So we write expression and instead of just subtracting the time without any probability, we could also include the probability. So for the time, we minus the time, just include the probability. Or for the count, we add instead of 1, we add...
But how do you want to tell the simulation to direct 20% of the parts here and 80% here?
So we are just calculating the count, right? So each time it add 0.8 to the other one and 0.2 to... Instead of adding 1 for the count, we add 0.8.
No.
So why is it not working? So
because these are just randomness. It doesn't necessarily mean that exactly 80% will go here or 20% will go here. These are just randomness that cause your entities to go in each one of the operations. And then later we will learn that we don't run this simulation only once. We run this actually many times for different replications, and each replication, yeah, we say 80% here and 20% here, but maybe when we run it in one replication, we see 75% here and 25% here. In another replication, we may see, I don't know, 19% here and 81% here. So like if 100 parts come, we may not see exactly 20 of them go here and exactly 80 of them go here. So those are just percentages.
Yeah, but I think it's deterministic, right? It's not like we don't have an expression like exponential distribution, so each time it gets a different percentage. We have a deterministic 80% of probability. So each time it goes with 80% chance to one node and 20% chance to the other node.
So then you say if
I think
we instead of adding the parts, we just add them 0.2, 0.2, 0.2, and here we add them 0.8, 0.8, 0.8.
Yeah, I think it should work here.
I wouldn't do that way.
I think the reason that the deterministic interpretation doesn't work is because with these decision nodes, you can think of it as every time you run the simulation, it samples a random number between 0 and 1. Mm-hmm. And if our threshold is 20% true, if that number is between 0 and 0.2, then it directs it to a failure. And if it's between 0.2 and 1, then it says the rework was successful. And so that sampling process does introduce randomness, so it's no longer deterministic.
Yeah, that's true actually. And that's why I said if we have 100 parts that come to the decision node, we may not see exactly 80 of them go to the salvage and 20 of them exactly get scrapped. Based on the random numbers that was generated in the decision module, we may see 81, for example, go to the salvage and 19 go to the scrap. But on average, that's 80%. On average, that's 20%. But I think based on what you said, that works if we really are sure that exactly 20 of that 100 parts go to the scrap and 80 of those go to the salvage. But based on the random numbers that are generated in the decision decision node to see which way they have to direct the part, we may see different numbers of scrap and salvage.
Yeah, okay. Yeah, I get it. And that's logically true, but it comes to my other question. I have another question that why your result was exactly the same as mine. Isn't it that the process comes with a random time? So if we have suppose that we have a very small simulation and we want to run it for only one instance. So for example, we want to wait until one part A arrives to the system and we have no process. So the time that part A comes to the system has a random distribution. And if we run it only once, the number that I get and the number that any other person that runs a simulation get should be different by 100% chance. But it's always the same. If you run it like 1,000 times, you're going to get the same result. So I don't understand how
it's not 1,000 times. So here we run it only for one replication, okay? And I told you guys, I think in previous session, that when simulation generates this, when we run the simulation, what is happening in the simulation is that behind the scene, simulation has a long string, many actually strings of the length of these strings are in the order of million. And random numbers are in these strings. Okay, so the way actually simulation works is that simulation generates a random number between 0 and 1 and then use that to generate a uniform or a normal or exponential or a variable or any other random number. Okay, so what is behind the scene is a long string of these random numbers between 0 and 1. And if I tell the simulation, okay, entities come to the system. First, I want to create a random variable that is coming from exponential with 30 minutes. Simulation picks one of the numbers in these long strings and then puts it in the formula to generate a random number from exponential with 30 minutes average, okay? And then use that in the simulation model. These strings are the same in all of our models, okay? Sometimes we may see different numbers because sometimes the way these strings are used in our simulations are different, or the seeds, the starting random numbers that are used in these strings are different. We may observe a little different numbers. However, if you and I are seeing similar numbers, it's just because the strings of random numbers that are used in my model, in my software and your software are the same. So our softwares are using similar string of random numbers. Are you using the virtual, are you using the desktop or your own?
No, I'm using the my desktop Viterbi like Access. I don't have it on my own computer, so I'm running it with the
on that one.
Yeah, on the enhanced desktop, like VMware software. Yeah.
Okay. Yeah. So that's what happens, and we see some similar numbers. And later, when we get to the replication concepts, we will see that even with one computer, when you run the same simulation for different replications, since each replication uses different set of random numbers, you observe different results. But as long as our computers are using the similar string of random numbers.
So each time, so are you saying that each time the computer actually runs, like when we are like assuming we have only one entering process, so for example parts A are arriving to the system, so each time we are going to find a time for parts A that comes to the system, simulation runs like a million strings of random number, or it's just the first random number that gets from that?
No, simulation has a string already. They have the string. So for generating the first random number, picks the first number in the string, and then the simulation needs, let's say the parts goes to the assignment, and I want to generate a triangular random number. Then simulation gets the second number from the string. Then the parts, then another part B comes to the system. I generate the third number in the string, and then just use these different strings to generate these random numbers.
Oh yeah, I get that. Yeah, thank you.
Sure. And then later also we will learn that like the possibility of using different strings for different random numbers that want to be generated in the simulation as well. Maybe for all the arrivals, I want to use this string. For all the processing time, I want to use these strings and so forth. So we can change that as well.
Thank you.
Sure. Okay, guys, we are almost done with the class time is almost over. What I actually wanted you guys to do is to open, if you go back to the folder for the previous section. This is the model that we had, right? So go to the folder for previous week, and you all have to have this model, okay? What I want you guys to do okay, let me just say it. What I want you guys to do is to save this model as a new model in the folder for this week 5, and then at the end of the name just add attributes, okay? And this is what I want you guys to add. It doesn't let me try. Okay, here. This is what I want you guys to do for this model. Okay, so save this model as a new model in the folder for week 5. At the end of the name of the model, add attributes. Then make these changes. I want you the customers that come to the system, they have different processing time at the loan. So let's say okay, let's say 20% of customers are VIP, rest are regular. Okay. VIP customers VIP customers have 30 seconds processing time for pricing their loans. So I want you to implement that, and then I also want you guys to calculate the cycle time and also count, calculate the cycle time for each customer type. I also count each, how many of each customer type left the system. Okay, save this model as a new model in the folder for week 5. At the end of the name, add attributes. And I want you to change this model, keep everything that is already in the model the same. I want you to make these changes. Of the customers that come to the system, 20% of them are VIP and the rest are regular. VIP customers, when they get to the pricing loan operation, their pricing is 30 seconds on average, exponentially distributed. Okay, so the VIP customers, the pricing, the loans, it's not 1 minute, it's 30 seconds. It's still exponentially distributed. And I want you to calculate the cycle time for each customer, the VIP and regular, and
Yes, sir.
tell me how many of them left the system. What's the question?
Yes. I know it's that my problem, because what I put it for the previously on the price loan is 1 hour.
Oh yeah, you put 1 hour. Okay, so let's say 30 minutes.
Okay.
Why did you say it's your problem? It's not your problem. So thank you for pointing that out. Yeah, it's the unit is hour. Sorry. Thanks for pointing that out. Yeah, so the VIP customers have 30 minutes on average, exponentially distributed processing time for pricing the loans. Yeah, keep everything else the same. And I want you guys to do that. So I want you guys to finish it and upload it tonight. Actually, I just give tonight because I know a couple of you are in China and the time-wise it may not work perfectly. So I give you by midnight today to finish this and upload it. I create an assignment folder on Blackboard, an assignment file on section on Blackboard where you guys can upload this. And just before I let you guys go, can you tell me how are you going to take care of this 20% thing? Where is the best place to put that? To tell the model that 20% of the customers are VIP and the rest are regular. Guys?
By adding an attribute.
Okay, no. So obviously for this 20% thing, you need a decision node, right? You need a decide module. My question is that where is the best place to put that decide module in this simulation?
Before the price loan.
Okay, before the price loan. Any other suggestion? Okay, so when you said before the price loan, I put it here. Before the price loan, I find out which customer is VIP and which customer is regular. In part 3, I have asked you guys to calculate the cycle time for each type of customers, meaning the time when they leave minus the time when they come into the system. Take that into account and tell me if putting the decide module right before price loan is going to help us to do that.
No.
Okay, where is the right place then?
Very beginning.
Right after the create modules. So this was actually a very good point. Thanks for answering. So if I put the decide module right here, that's not wrong. That's correct. You can just say, okay, every customer that comes, no matter what, if they are VIP or regular, they always go to check credits. They always go to prepare contracts. And for all of them, these times are the same. So their time, their processing time only changes when they come to pricing the loan. So I just decide here, I just put the decide module right before pricing the loans and decide, okay, who is VIP and who is regular, and I just give them different processing time and they go to the processing loan and I'm all good. And this is not wrong. This is correct, 100%. However, if I ask you to calculate the cycle time, the time that they stay in the system for each VIP and regular customers separately, putting it before the price time wouldn't enable you to do that. It's not wrong, but wouldn't enable you to answer part 3. To answer part 3, you have to decide right when they come to the system, if they are VIP or regular, so that you can right there record their arrival process, any type they are, and then when they enter the system, when they want to exit the system, you can just know when they have left the system. So to calculate the cycle time correctly for each one of them. Okay. So make sure to pay attention to these parts to know where is the best place to put a specific module and so forth.
Sorry, Professor.
Go ahead.
One more quick question. Would you mind to open like those process? I just want to make sure I have the correct processing time.
So all of them are 1 hour exponential. All of them.
Okay.
1 hour, 1 hour, 1 hour, 1 hour.
Thank you.
They are all hour, and then inter-arrival also was 1.25 hour exponentially distributed. Okay, so make sure to make these changes and then upload your model. I'll create a folder on Blackboard and I will email you guys where is that folder so that you guys can upload your model. I also assign your homework. Hopefully, if not today, by tomorrow the latest, and you will have again 1 week to upload, and tomorrow is the deadline for the homework that you already have, so make sure to upload that on time. That's all I have for today. Any question?
Professor, can you show the setup for the model, please?
Setup? The run
Yeah,
setup?
the run setup, yes.
I'm not sure if this is the one I told, but just for the sake of just making sure all of us get similar numbers, did you guys put 100 or 20? Just put 20 for this one. I don't remember exactly what was the number we put for the previous run, but just so that we all get similar numbers, or just put 100. Sorry, let's run this for 100 hours, and then report your results in minutes. Or no, actually, report in hours. Everything is in hours. So run this simulation for 100 hours and report your results in hours too. And 1 replication, and that's all I need from you by the end of tonight. Any question, guys?